Welcome to the Ray Code. In this video, we're going to explore the prototype design pattern using Python, one of the creational design patterns described by the Game 4. We'll begin with two important questions. What is a prototype design pattern and why we should want to use it? From there, we'll examine the UML diagram and look at the participants that make the prototype pattern work. Then we'll move to Python and walk through a working code example where we'll see how new objects can be created by cloning existing objects rather than building them from scratch. And finally, we'll finish with a SWOT analysis looking at the strengths, weaknesses, opportunities, and threats using the prototype in your own software. You'll find the source code for this example at my GitHub along with an accompanying article posted at the Ray Code. Visit theraycode.com for courses where you can take these concepts further. You can also follow the Ray Code on Facebook, X, and LinkedIn for new videos, articles, and updates. So with that in mind, let's get started with the prototype design pattern using Python. What is a prototype design pattern? The prototype design pattern is a creational design pattern from the Game 4. Prototype creates new objects by copying or cloning an existing object rather than constructing each new object from scratch. In Python, this idea fits naturally with copy module. A prototype object can be duplicated by using copy.copy for a shallow copy or copy.deepCopy for a deep copy. In Python, this idea naturally fits with copy module. A prototype object can be duplicated using copy.copy for a shallow copy or copy.deepCopy for a deep copy. Instead of saying, build me another object and configure everything again, the prototype says, I've already have an object configured the way I want. Give me a copy of it. Why should a Python student study the prototype design pattern? Learn object creation by constructors. Prototype demonstrates that creating an object does not always require calling a class constructor and rebuilding its state. Understand shallow and deep copying. Studying prototype provides a practical reason to understand Python's copy.copy and copy.deepCopy. We use existing object configuration. A configured object can serve as a template for creating additional objects with similar state. Reduce complicated initialization. Cloning can avoid repeatedly performing complex setup when appropriate object already exists. Reduce dependency on concrete classes. Client code can request a clone without needing to know exactly how a particular concrete object is constructed. Understanding mutable object state. Prototype helps expose an important Python concept. Copied objects may still share reference to mutable objects such as lists and dictionaries. Practice object-oriented polymorphism. Different prototype classes can provide a common clone operation while controlling how their own objects are copied. Recognize when copying is better than rebuilding. Prototype teaches students to evaluate whether creating an object from an existing example is simpler than constructing it from the beginning. Learn a Gang of 4 creational pattern. Prototype belongs with Abstract Factory, Builder, Factory Method, and Singleton in the Gang of 4 creational pattern family. Improved software design decisions. Understanding prototype gives a Python programmer another option when deciding how objects should be created, configured, and duplicated. Student summary. Prototype means creating a new object by copying an existing object. For a Python student, the most important lesson is to not simply learn copy, it is understanding when cloning an existing configured object is better designed than constructing and configuring another object from scratch. Creational pattern prototype with consideration in Python. Participant prototype declares the interface for cloning an existing object. In Python, this commonly represents a base class or an abstract base class containing a method such as clone. Defines the cloning contract that ConcretePrototype objects provide. Allows the client to request copies without depending on the concrete class of object being copied. Participant ConcretePrototype implements the cloning operation defined by prototype. Creates a new object whose state is copied from the existing prototype. In Python, cloning can commonly use copy.copy for shadow copy or copy.deepcopy when nested mutable objects must also be copied. Allows the client to request copies without depending on the concrete class of the object being copied. Participant client creates new objects by asking a prototype to clone itself. Works through the prototype interface instead of directly constructing a specific concrete prototype. In Python, the client works object references and normally does not perform explicit pointer or memory management. Can create differently configured objects by cloning different prototype instances rather than repeating their instantiation logic. Student summary. Prototype defines how an object can be cloned. It gives the client a common way to request a copy. ConcretePrototype performs the actual copy in Python. Copy.copy and copy.decopy are common tools for implementing this responsibility. Client requests new objects by cloning existing prototypes instead of constructing and configuring every object from scratch. Hello, my name is Ray, and I'm the Ray in the Ray code. In this show, I plan to cover the prototype design pattern, and I'll be using Python. The prototype design pattern creates new objects by cloning an existing object instead of constructing one from scratch. We begin our project with a prototype.py file. At the top, we include support for ABC and the abstract method. We start with the class structure prototype, which accepts an AP object. We define the clone method, which accepts self, and we pass. The next Python class I will create is the ConcretePrototype. At the top, we import copy. From prototype, we import prototype, the first class we create for this project. We add the class structure for the ConcretePrototype, which accepts a prototype object. We initialize self with a state, and we set the state of self to the state. We clone self and return a deep copy of self. In the client, we will do our demonstration. We define a static method, demonstrate, of which we will pass in a prototype object. We set clone1 to a clone of the prototype, and we set a different element to clone2 of the same prototype. Let's demonstrate that these two elements are different. We set the state of clone1 to state A, and we set the state of the other element to state B. And we return the clones, clone1 and clone2. Now let's go to main method for our demo. We start by importing the ConcretePrototype class. We also import the client. We set a prototype object to the ConcretePrototype. We set clone1 and 2 to the same client to demonstrate the prototype. We print the prototype state. We print the state of clone1. We print the state of clone2. I think we are ready for our demo. We see the original state, state A, and state B. My name is Ray. Always go with smile. SWOT analysis for the design pattern prototype for a Python student. S. Strengths. Simple object duplication. Copies existing objects quickly without repeatedly evoking complex constructors. Flexible runtime cloning creates customized instances dynamically using Python's powerful object copying capabilities. Reduced initialization costs. Reusers prepared objects, minimizing expensive setup operations for new instances. W. Weakness. Complex deep copying. Nested object references complicate implementing correct deep cloning behavior. Hidden shared state. Shadow copies may unintentionally share mutable data between cloned objects. Clone maintenance overhead. Every class requires careful cloning logic as attributes evolve over time. O. Opportunities. Game object templates. Clone enemies, characters, and items efficiently from predefined prototype object. Configuration replication. Duplicate application settings quickly while modifying only required configuration values. Framework integration benefits. Combine prototype with factory or builder for flexible object creation workflows. T. Threats. Improper copy implementation. Incorrect clone methods introduce subtle bugs that are difficult to diagnose. Memory consumption growth. Excessive cloned objects increase application memory usage and management complexity. Unnecessary pattern usage. Simple constructors may outperform prototype, reducing readability without meaningful benefits. And that brings us to the end of our look at the prototype design pattern using Python. We started by asking, what is a prototype design pattern and why might we want to use it? We then examined the UML and its participants and walked through some Python code and finished with a SWOT analysis to consider both the benefits and trade-offs of using this design pattern. Remember, the complete source code is available on my GitHub, so download it, run it, change it, and experiment with it yourself. You can also visit theredcode.org for company article and additional design pattern material. Visit theredcode.com for courses from the Red Code. Follow the Red Code on Facebook, X, LinkedIn to keep up with Red Code content. If this video has helped you, remember to like, subscribe, and turn on notifications so you don't miss the next design pattern. Thank you for spending some time here with me at the Red Code. Keep learning, keep coding, and I'll see you in the next video.